So today on the VSS 1250 channel, we have this Sundstrand speed adder. Now this one's kind of in basket case territory. It's missing quite a few parts. You can see it's missing the crank, and unfortunately it's also missing the patent and paper holder. And if you look at the bottom, it's missing 3 of its 4 feet. Now luckily it does have all the keys though, but I think I'm definitely going to have to find a parts machine for this, because I definitely can't make something to replace the patent. So I'm definitely going to have to get a parts machine, I think, for this to get the patent and the crank, and hopefully the parts machine will have at least a couple of feet I can use put on the bottom here. But until I get the parts machine, we can at least see if we can get this thing to work. So when the parts machine comes, I can just swap those parts over and it should be good. Fortunately, turn that a little bit, but not very much. I'm going to have to take the cover off so I can get a better grip on here, I think. You can see there's a little key in there. Hopefully I can grab onto that. So let's get the cover off and see what's inside here. Okay, so I got the cover off. I removed 2 screws like this that were right on either side, right in the middle here. And then I loosened up, see this on the machine, 2 screws on the back here. This one and this one, I loosened that up, and then you can lift this up and then fit those screws for these holes to take that off. And the cover basically just lifts off with this piece coming off, and this is just the piece that went down here under where the crank goes. So we've got the cover off. You can take a look at what we've got in here. So here's our little tiny dampener. That's a lot smaller than the Rose one. We've got our key rods here. So probably when you push one of the keys, it's gonna activate that, I guess. Okay, that's interesting. Well, that's a really weird design. Okay, so you can see here, this is our pegboard with the little pegs that push in every time you push a key. Now usually on these machines, and turn this so you can see better. Maybe. No, you can't see better that way. Anyway, usually on these machines, the pegboard slides with every key press. So like it would start, all the way over on the right. Then when you push a key, they'll push in one pin in that column, and then pegboard would move over one position to line up with the rods for the next pin to be punched in the next column. But on this machine, the actual rods move and the pegboard is stationary. So you can see if I release this, the rods actually swing back to point at different positions in the pegboard. It's very, very interesting. So that's cool how that works. Sure. Okay, and the pegboard, so you can kind of see how it's actually curved to match the arc that this sweeps through. That is interesting. Cool. Okay. So the keys are stuck. That one's kind of unstuck. I'm looking at what I'm doing. Looks like this is a plastic piece. That's interesting. So it looks like the machine is probably out through a cycle. Looking at what this actually drives. It looks like it just lifts this up and down to put the machine through a cycle. But this is stuck, it seems. So this is probably the extent of the stroke, because you can't really lift this up anymore. It starts pulling that way, and this was like a pivot point, so it's not going to move that way. So this must be the end of the stroke, and this is supposed to come back down, but it's not. So I think I'm going to spend a little bit of time looking at that and see if I can figure out how this works and see if I can figure out why it's jammed. Okay, so I was actually wrong before. This is in the home position, it does rotate this way. This whole thing actually lifts up and the pivot point is down here. So you can see right down there's an oil hole, there's a shaft that runs through there. And you can see the linkage there bolted onto that shaft goes up and is attached to this rod. So when you rotate the crank this way, it actually pulls this up, which rotates the main rod down here through that linkage. So if I use my big pliers here, I can actually turn the crank. I'm not turning it far enough. Well, it didn't quite go back, did it? Yeah, it's not quite all the way home with me. There we go. So did that free up our keys? No. Our keys are still stuck. So that probably means you're going to have to take this green plastic off, which probably means you're going to have to take all the key stems off so I can figure out why the keys are jammed. That one's free. Oh, that one's free. Okay, maybe they're just stuck by dirt or something then. Some of them are free. I think our pegs might be frozen now. See if any of these come up. I'll save some numbers. Okay, so that's not too bad. It did not clear, not clear the keyboard though. Oh, I see. It's supposed to go all the way over that way? That can't make any sense. Actually, yes, it does make sense. If I looked at the case, you'll see the home position is here, and then hundreds, thousands, millions. This is backwards from normal, because usually the pointer moves right to left as you enter, whereas this one it moves left to right. So now we're home. Let's see if I can enter. I can enter some of them. Actually, just 0, 3, 8. Looks like just 0, 3, and 8. I can enter. So I've entered a bunch of 0s, 3s, and 8s. My tripod is collapsing. Let's see if we get a bunch of 0, 3s, and 8s on these lifters here. So you can actually see them. Looks good so far. Grip this properly. Okay, so that seems to work. And now see, it went back all the way. You can see that. It went back all the way to the left, ready to enter more numbers. So I think what I'm going to do now is try and get a look in here and see if I can figure out why some of these keys are jammed. Okay, so I was able to take this little keyboard module out. You have to take off quite a few springs, then there's 4 screws that hold it in. You also have to take out a very teeny tiny screw that screws in right here on this lever, and that prevents it from sliding past here. So they take that screw so you can slide it past here to get this out. I also had to put the machine most of the way through a cycle so that this would retract back far enough that I could wiggle this out, because as you see it has this piece down here actually fits down into a hole here. So I had to get this back far enough to give this enough lever that I can lift it up just enough to wiggle the keyboard out and over the front lip here. So this is out. I also take off one screw here, which released this piece, since didn't want to come off. Oh, it comes off that way. Anyway, it's off now. So it looked to me like these rods here are frozen, and that's why things like 7, you can see the bars moving down here, but they're not moving up here, they're like frozen. See, 8 pops out. This didn't go over far enough. Okay, so it looks like each key has its own one of these little rockers here. And so when I push down 0, 0's rocker also goes down. And at the same time as I'm rocking that, you can see 0's plunger punches out the end. By the way, this is the lock. If this is back, the keys are locked, but okay. So if this is back, the keys are locked, but the rockers are still movable. This is forward, the keys are unlocked. So basically that's how it works. You can see each key has some little rocker here. You see this is 1's rocker, that one's frozen. Okay, that's 1 or 2. This one here is 3 because you see the 3 key going down. When I hit that one, you see 3's plunger coming out. 2's plunger doesn't want to come out, so that's stuck, probably because the key is stuck. If I hit 7, you can see it wants to go. You can see the rod kind of twitching, but the end of the rod is stuck. So I think that's the case with a couple of these, like 5. 5 wants to go too, but its rod is stuck in the end here. Some of them, I think the keys, like 1 and 2, the keys are actually frozen in this plate here. So I'm going to work on seeing if I can get some of this loosened up and see if, I hope I don't have to pull all these keys off to take this plate off, but if I do, I will. Okay, so I managed to free up the rest of the keys here. So if I hold this is the lock, if I hold the lock forward, then I press each key, you can watch this little plunger pop out the end there. Except 9, which has no plunger. And the reason for that is because the way that this machine works is, this is the pegboard here, and when you hit key, say I hit 8, it's going to push that peg in. Actually, I pushed 2 pegs in, but this is the peg for 8 is on the top, then 7, then 6 all the way down to the peg for 0 on the bottom. If I push this over, it's going to clear those. And let me get this a little bit closer here. So these levers down here are attached to this thing. So if I slide this over, you can see those levers move over down here in the bottom. And when you run the machine through a cycle, these levers are going to raise up until they're stopped by one of the pegs being pushed out. So for example, if I have this, we'll just start, say, here, and I push in this peg, and we'll push in one of the middle pegs up here, if I can. And then if I run the machine through a cycle, you can watch those. Well, some of them are raising up. Not quite sure why those are raising up. They shouldn't be raising up. But if you watch the 2 here, as you can see, this one went so far and stopped, and this one didn't go up at all because it stopped by the bottom peg. This one raised up until it was stopped by that middle peg. Not quite sure why these other ones went up. They should not have, because those should be blocked since this wasn't over far enough. So I'm going to have to take a look into that. Basically, when this is all the way over, now I pushed a peg in. So if you push a peg in when this thing is all the way over, then it won't go back out because the peg is in. So I'm going to have to, when this thing is back all the way, the risers over here shouldn't rise, because once it's back all the way, we haven't entered any numbers. This moves over 1 position for each number we've entered, so all the bars that are behind here shouldn't raise at all since there's no number entered there. So I'm going to have to take a look into why that's not working properly. But I think you get the idea of basically how this works. The pegs set the number, and those bars rise up until they're stopped by the peg, and the amount that they rise up is proportionate to the amount that the print heads rise up, so that the right number is lined up to be printed, and that also drives a register, which is down inside here, forward the appropriate number of positions. So I'm going to take a look at why those are rising up when they shouldn't, and also get these pegs undone. And then we're also going to take a look at the control mechanism as far as like totaling and stuff. So you can see all the different functions we have. We have repeat, backspace, non-print, total, non-add, and lock. Now the lock is pretty simple. All that does is, if I can get this in shot here. So normally when this thing is all the way forward, I can push keys down. If I push lock down, it just pushes this back, and now the keyboard is locked. If I take lock off, then this can go forward again, and I can push keys. Now normally this would be under spring tension held forward, so that as soon as you release lock, this would pop back forward, but since I have the keyboard out, that's not the case, but normally it would. I've also noticed that if I have no pegs pushed, which, let me get these unstuck first so I can show. Okay, so I got those two pegs pushed out, and now I can slide this all the way over. And once it's all the way over with no pegs pushed in, the visors should all rise up full height. But if I do that, you can see that this one's stuck, this one doesn't want to come up all the way. Some of these other ones here are also stuck. That one's stuck, this one doesn't want to come up all the way. So we're going to have to look into why that is. I'm not sure if the machine is like trying to do a total and that's why they won't rise up, but I'm not quite sure. I'm going to have to take a look into that and see if I can figure that out. So luckily this machine isn't quite as stuck as the Burroughs was, but definitely still has some issues that we're going to have to look at. Also, this doesn't go back all the way either. So this should spring back all the way to the home position, but it doesn't. Now that could also be because, this spring is not on because the keyboard's out or something like that. I'm not quite sure. So we're going to have to take a look into that too. But I want to get all the risers working properly before I put the keyboard back in, so I have access to this section down here. Though technically, I would have access anyway, because if you stand this machine up, you're going to take this plate off the bottom and get access to that area too. So based on what I can tell so far, it looks like the way this machine operates is, you enter numbers normally and they'll add in when you pull the handle. If you don't enter any numbers and you pull the handle, it does a subtotal. And then if you push the total button and pull the handle, it'll, do the regular total and clear out the machine. That's what it looks like to me. Now, I'm not sure if you can see, but all the way down in here, which you probably can't see. So this screw right here is the end of the shaft containing gears, and those gears are the register. The position of the gears determines what number is being stored in that column. And then there's one gear per column. Back here, driving the gears, are the risers. It's kind of dark, but so this right here is a gear, and it's being driven by the riser right next to it. So when you run the machine, that riser will rise up, and then that's the print head's attached to the top of that riser, and that drives the gear forward the appropriate number of positions. Now each gear has two little tabs sticking out of it. I'm not sure if you can see, there's one right there. Probably can't see that. Is that kind of little shiny thing? I think that's it. That's the little tab that sticks out on the back side, and then there's one directly across from that on the other side of the gear. And those are both those tabs are used for carrying and locking. So when you want to do a total or subtotal, there's little arms that come out, and that tab will hit those arms and stop the gear in the 0 position. So say the gear was in 5, then the gear will rotate 5 teeth until that arm hits the stop lever, and that will raise the riser up, or allow the riser to raise up 5 positions to point out a 5 for your total or subtotal. The difference between total and subtotal is when, after the riser has raised up, for subtotal, the riser will drop back down and turn the gear backwards the exact number of positions that it went forwards, and then it will save the number that it had in it originally. For total, the register disengages on the downstroke, so that way the riser can fall back down but leave the gear in the 0 position. Now, opposite these tabs on this side are the little carry triggers, and those tabs that stick off the gears will also trigger the carry triggers when it gets to right position. So basically what was happening was those tabs were always engaged, so because these 2 gears in the end were already at 0, the tabs were engaging and not allowing them to turn any further. Now you disengage those tabs by pushing this little button in here. So you can see that pushing this in moves this linkage here, and that linkage disengages those locking tabs. And whenever you have something entered on the keyboard, I think it holds this in so that the machine disengages those tabs and allows whatever you've entered on the keyboard to be added in. If you have nothing on the keyboard, this is released, and then the machine does a subtotal via the locking tabs, locking those gears in. That seems to be the way that it works. It's still a bit sticky as far as, it doesn't always want to do a total and different stuff, so I'm still going to have to do some more looking and cleaning on this, but so far that's how I think this machine is supposed to work. This lever over here is the total lever. I'm not quite sure how exactly it engages because it goes up and down and it goes in and out. I'm not quite sure what the different positions actually mean. It seems to me that if I hold it out and push it down, it will usually do a total, but sometimes it gets stuck. So there's some stuff going on there that I'm not so sure about. Let me lean this over on the side so you can see the bottom of it. So I removed that panel that went on the bottom here so you can get an idea of what's going on here. So you can see these are the bottoms of all the risers. You can see up here, these are the gears, the register gears. And there's teeth on the risers here. So these teeth here drive those gears for the register. So whenever and then this is what slides over for the rack in the front. See, if I slide this up, entered all the way, then that means that these risers, these pins here, will slide up until they're stopped by one of the pegs sticking out the back of the pegboard. See, if I push this peg in, see it sticks out the back right here, so that way when you have this up there, this pin will hit on that tab, and that will determine how far the riser is allowed to go up, which will in turn determine how far the register is driven and also what number is printed on the paper. Now if I have this all the way up and I hit one of these in, when it goes back down, it will clear that out. Got a spring floating around here. Most of those, all those springs actually came off the front when I took the keyboard out. There was a lot of different springs holding things together in there. So I think that's about all I have to say for the mechanism for now. I'm going to get to working on seeing why it jams sometimes when I try to do a total, so I can figure that out. And I might put the keyboard back in just so I can see how it works with the proper total actuation, actuated by the key instead of just me pushing on the lever. But it's starting to make some sense now. I just think this is a really interesting design. I've never seen it done this way before. Usually the pegboard is what moves, against, usually these pins are stationary and then the pegboard slides past the pins the appropriate number of positions. Kind of interesting how they did it this way with the sliding thing here. I think that's an interesting design. So I've oiled up and reinstalled the keyboard, and I think I got everything back where it belongs. There's a spring that goes from here down to there. A spring that goes from here down to there. This is a heavier spring. There's a spring that goes from here to a peg on the bottom of the board there. I reconnected this linkage here. I had to take this bolt out to get it off, so I reconnected that linkage. I put this back on, that just screws on there like that. It goes around here. On this side, this bolt goes through here. This is what connects the locking mechanism. And there's a spring that goes from here up to here, and that's what pulls the rack of punchers over every time you press a key. And there's another spring down here that goes from the totaling lever to this peg on the bottom of the totaling key. So it seems to be operational now. See, as I enter numbers here, this thing moves over each time, ready to punch the next number in. And if I go through a cycle, you'll see the numbers rise up on the stampers, ready to stamp. And now the machine automatically returns fully to its home position. And before, when I let it go, it would stop, with this pointed up a little bit, but now it returns fully home. So I think that some of these springs over here may be helping with that. And also, you can see that this thing has returned home, and it's pointing at the first column again. So now, if I do an empty crank, this screw here should punch this out. You can see that it does. Now if I do another crank, it should do a subtotal. You can see that it is. Then if I hold down the total button and do one, it should do a total and clear everything out. So now if I do a subtotal, there should be nothing happening up here. And that's the case, so that means that total now works. So there must be some sort of interaction with the way this spring down here, you can even see what I'm talking about. This spring down here connects to that total lever. So there must be some interaction with this pulling it forward or something at just the right time to get the total not to jam like I was having. So this should be okay now. I definitely want to do some cleaning on the keyboard, this little plastic thing here, and also want to do a lot more oiling of the mechanism because I've only oiled some of the parts. I did have to free up this piece here that's the non-add button, so I had to free that up because that's somehow after the total. When you push the total down, this also moves down with the total lever, so that was also part of the problem, I think. So that's freed up. Does this have a backspacer? So if I enter, say, 1, 2, 4 instead of 1, 2, 3, I can hit backspace, and you can see it pushes it back, pushes it over one place, and I can hit a 3. The problem is if you want to clear the whole keyboard, or you just want to start over, you just have to backspace everything. You clear it all out. But I think that we are pretty much good as far as the adding mechanism. Everything seems to work now, I think. This lock, that just pushes down so you can't push any keys. That's okay, and then when you release it, you can push keys again. Backspace works. This is the plate on the back here. I think this is the serial number. I'm not sure what these numbers are. 900 maybe because it has 9 digits. Not quite sure about that. I don't know what this 21 means either. Unless that's the year it was manufactured. So the latest patent date on there is 1921, it looks like. So maybe that's the year it was manufactured. I don't think the Burroughs had the patents on, and the burrs just had the serial number stamped right on the front. Okay, I think I've mainly figured out how exactly this machine works now. I don't know if you can see all the way up here these little tabby things. These things right here, see there's like a little hook on the end of it? I had assumed that those were the carry triggers, that when the extra tooth that sticks off the gear hit that would trigger a carry. That's actually incorrect. The tooth that I was complaining about earlier was blocking the wheel from turning. That tooth is both the carry trigger and the stop for totaling. So normally the wheel turns one direction and when it's adding, and then when it's totaling it turns backwards until it hits that stop, and then it can't go past that stop, and then that the visor rises a proportionate amount to that to get your total. When you're adding in the forward motion, then when that tooth hits that pin, it pushes the pin down, and that triggers a carry to the next column. And the way the carries work, it seems that when it triggers the carry pin, that releases a stop that allows these bars to drop lower one position. So for example, if you were adding say 5 in, normally this would rise up 5 positions, and then on its way back down, it would drive the register forward 5 positions. However, if you were carrying over from the next column, this would rise up 5 positions, and then on its way back down, it would drive the register 5 positions, but because the carry was triggered from the previous column, this would actually drop lower than its normal stop, and actually drive the register forward 6 positions instead of 5, because it now has further travel. And then when you do the next crank, then it would rise back up again, and then fall back down to its normal stop and be reset, ready for the next time. So that's why on all these adding machines that I've worked on so far, like the Burrows and, although I don't think the Victor was that way, but the Burrows was that way, and the Swift was that way, and this one's that way, that you have to do an extra crank before you do the total, because you have to reset all of these to their proper stops before it'll register the total correctly. Those things that I pointed out earlier that I thought were the carry triggers are actually the stops for a non-add. So basically when you do a non-add, that lock will come in and lock the register so that it can't move, and that's how you get a non-add. So I hope that basically sums up how this works. I mean, there's a lot back here that you can't really see, and I can't see it either, but based on what I've observed from the parts that I can see, that seems to be how this works basically. And of course I've got a mess of oil all over everything now, so I have to clean some of this up before I put it back together. So you can see I took the keys off and took that green plate off, and there's quite a bit of rust under it. That green thing was just a piece of plastic. Just a piece of green plastic. I cleaned that up. Unfortunately, I can't take this plate off because the way this is built is basically pinned together. So I'm not sure if you can see this little mark here. That is the side panel here. They had a little tab that they pushed through here and then pounded it flat. And then that's here. I think there's one here, there's one here, and there's one up here as well. And that's how they put this together. So the only way to get it apart would be to either drill or somehow cut this out, and all of them out, and then you could take this apart, but then you'd have to somehow figure out how to put it back together. So I'm not going to be doing that. I think I'm going to try and clean up as much as I can of this with a wire brush or something, and then just coat the whole thing in oil to prevent further rust before I put the green plastic back on. I'm not sure why there's so much rust here, because this is the most rust of anywhere on the machine. I mean, most of the pieces of the machine have no rust at all. Like down here, there's just, a few spots. If that's even rust, that might actually be grease. Old grease stains. Some of this I think is rust, but hardly any compared to up here. So I mean, it's not like the machine was underwater or anything, because if that was the case, then there'd be a lot more rust, all down the mechanism. But so I don't know if that green plastic, absorbs moisture or something, but definitely a lot of rust there. And that's why all the keys were frozen, or rusted in place. But I managed to break them all free. Just for testing purposes, I managed to get these pliers to lock, and then you can just put them on here, and they kind of work as a handle. They don't stay on very well, but it's good enough for testing. Definitely better than me trying to pull on this to get it to go. So I'm going to try and clean this up and then put the keys back on. Some of them were pretty hard to get off. This one, you can see the new cracks in it. Part of this cracked off and that piece cracked off, so I glued that back together. So unfortunately, what happens a lot of times when you pull these keys off, but I couldn't see any other way to really clean that green plastic very well without taking the green plastic off. And I'm glad that I did, so I could see this and try and clean some of it up. So you can see the post machine has arrived right here. I've already taken the feet off of it because some of the feet were damaged in shipping. This one was fine. It has some cracks in it, so I just filled in the cracks with some super glue just to make sure that it doesn't come apart, because the other ones did come apart. So I've just glued these back together as best I can. They're definitely missing some pieces, and I think there was some deformation of the rubber because they don't fit back together perfectly. But as long as they support the machine, that's all that's important, and I think they will. The one from the back was even worse shape. There's quite a few pieces missing from that one, but I think it has enough on the bottom to support the machine. This piece on the top is actually a stud that goes all the way down through. It has one bolt on the top and then another bolt down here on the bottom, and then that bottom bolt just rests right on this rubber here. So I think they'll be good enough to support the machine. They're going to be underneath, so I don't think you'll see that much of them. I'll put the two best ones in the front here. See, there's still one left here, and this other one that's not that bad you can put on this other side here. They just screw right in. This one seems a bit shorter than that one. That's unfortunate. See how this one's kind of mushroomed out on the bottom. So this one looks like it's been squashed a little bit, whereas that one's probably the original shape. But I think it will definitely be better than resting on the plate there, which is what has been happening. Assuming that these feet are actually tall enough to keep it off the plate, which hopefully they will be. So I'll have to see about that. So you can see that the post machine did come with a carriage, which is pretty dirty. So I think I'm going to start by seeing if I can clean that up. And I've also got a handle, so that's good. Hopefully, I think. Well, take a look at that. I can't imagine they'd have two different sizes. I think just the end of this shaft. Yeah, the end of the shaft has some chew marks on it. So this little piece here actually comes off pretty easy. I sanded this some more and I got the crank to, slide on not too bad. But I took it off because you can see there's a little oil hole here, and I didn't want the metal shavings from filing, or sanding rather, to get down in there and grind around on the shaft. So I just took this off and cleaned up the shaft and also this shaft. I'll just put a bunch of oil on here. It should just slide on. So lift this up. Oops, I'll just drop this way. you can see this thing here goes in that groove there, and then there's a spring that goes from a pin on the shaft down to a little post on this piece so that it holds the shaft in. So that if you move this to an open space, the shaft, see, is still held in the groove, it doesn't fall out of the groove. So I'll also dump some oil on that. So that's all lubricated. And then there's a screw, which goes in the end here. Just dump some oil down the oil hole just for good measure. And this should go on. And then it snaps in because of the little ball there holds the crank on. And now, we have our crank back. Well, back, we never had one to begin with. Now we have a crank. So I'm thinking that this thing is supposed to rotate on there, but it's not. So let's see if we can get this apart. Maybe. There's quite a bit of dust in there. So, yeah, it's tight. Let me see if I can work that off and oil that somehow. So I wrapped the paper towel around this and then used the pliers to try to work it off. Now it seems to have come off, and I'm not even showing it. I don't really see any marks. Oh, maybe there's one little mark there. Not sure that's from the pliers or not. Doesn't seem too bad though. So I got that off, and you can see how crusty this is. I think I'll probably just go around this. I'll wipe it off first. So I just go around a little bit with the sandpaper. I'll put some oil on that and put that back together. Not quite sure if this crank is aluminum or not. See, it's definitely pretty crusty. Dust coming out of there. Alright, so I got this cleaned up. I used some lacquer thinner and some sandpaper and cleaned that up. I spun a little bit of sandpaper up into a little roll and shoved it down here and worked that out, and that seemed to get a bunch of the dirt out. So we put this back on here. It spins pretty free now. I'm gonna put a bunch of oil on there. That's probably too much, but that's okay. I think that will work nicely. Alright, so that's fixed. Wipe some of the excess oil off here, since sometimes oil and rubber do not like to coincide. Of course, this thing is so hard, being around for nearly 100 years, that perhaps a little bit of oil would soften up a little bit. Okay, so we've got our crank. As far as the keyboard goes, I used the wire brush to get some of the rust off that I could, and then I just doused the whole thing in oil, so you can see there's some excess oil sitting there. So hopefully the oil that's on there will prevent any future rust from forming. So let me just give this